know you're surprised, Michelle. I'll be your teacher this morning.
Yay!
Just checking to see what you already know, what you have learned about the activity series, see how you can apply that and make predictions based on how reactive certain metals are. You probably know a little bit about how reactive they are with water, with oxygen, and with acids. So I'll be asking you some questions, but to get us started and to make that connection, you have a do now. So we have 5 minutes to complete this, then we're going to discuss your answers before we move into today's lesson. So I'll give you a chance to look at this, look through it, and make sure we understand what we're doing. I'll come around and check that you understand what we're doing. We're making somewhat of a connection as well to your math classes. In math, you probably do algebra, and so I made the connection to math so you can see how math can be related to chemistry or chemistry topics sometimes, but this is not the clearest connection. Let's see what you get. So take some time to look at it. If you have any questions, raise your hand, and I'll come around and check. We're making up. Guys, any questions? Make sense to you what you have to try to do with that? Those of you just came in, I'll be teaching a class today, just checking to see what you have learned already about the reactivity series, about any predictions you can make about how they react with air, water, and acid in particular. I might go back and review a couple of those to see if you guys can make some choices on that. So quickly find your seat. Maybe I'll just keep it. What do you do? They're not spots.
Make sure the table smells like metal. That's what I'm saying.
Okay, guys. That's... Question, Megan?
Yeah.
Don't worry. Other people should follow me too. But did you know it?
Yeah.
All right. Thanks, Katia. Katia and Ezra brought something to my attention. Brandy brought it to my attention before class started, that I had already written the answer at the bottom of the paper. And initially I was wondering why everybody had the answer correct. I was happy. I thought that meant you really learned this. So we'll find out in a few minutes if you really have learned it. So this means all of you can tell me what answer I was looking for, but is there any volunteer to explain how you got this process? Because this is where we're going. I was checking to see if you already knew anything about this, so that by the end of this lesson, you'll be able to talk about these single replacement or single displacement activities or reactions, and talk about what a displacement reaction looks like. Marquis.
Just like when you take an element and mix it with acids, I'll start from compound to compound, and it also creates hydrogen gas when it mixes. And with hydrochloric acid, it will always be a chloride. With sulfuric acid, it will be a sulfate, and nitric acid.
That's beautiful. So, did everybody know that? Katia, did you hear that?
Yeah.
I couldn't have said it better myself. Marquis said that just like, now in a class like this, we want you to experience science like a scientist. Marquis said that very scientifically. Sometimes in the middle school, or even high school, students they say it right, but it's not as scientific as that. He really hit that on the head. He talked about when you have a metal and you place it in an acid, that two things, well, he didn't talk about the second thing, that something is formed. He said a chloride is formed and a hydrogen gas is given off. So I didn't know if you guys knew that. I was prepared to demonstrate that and ask you questions about it, but obviously you already know that part of it. You guys, you realize that, but does anybody maybe Marquis or anybody could tell me what's that chloride called? When you put, let's use that example, like let's say we had zinc, like the example you had on the do now. You have zinc and you have hydrochloric acid. And he said that it's going to be a chloride. You said it was zinc chloride. Most people wrote zinc chloride and hydrogen. What would we call that zinc chloride? That has a special name. It's a compound, right? But that compound has another name. What if it was? Did you get a teacher demo? I think I walked by and I saw this happen. Has anybody seen a teacher drop any sodium in some water?
Yeah.
And did anybody talk about what was given off then?
Hydrogen gas.
Hydrogen gas was given off. How many of you have ever, or have you wondered what would happen if you put sodium in hydrochloric acid?
It would make
Anybody?
Yes, it would.
Say that louder.
An explosion.
It would be an explosion, because those are the things that we were looking for. What you knew about this reactivity series. Sodium is so reactive. It's really reactive, isn't it? So it reacts with water. So that's how I knew that you guys must have, that some metals react more vigorously with water. If you put the zinc in water, what happens?
Nothing.
Okay, so it would take a much longer time to react. That's all. It still reacts with water. Sodium's so reactive, it even reacts with air. I'm sure that you might have seen when it was first cut, it was shiny, and in a few minutes it was dull. Those are the kinds of things you might have seen, but we're moving on from that onto today's lesson. So the reason why I brought up sodium was because so I could introduce you to what these compounds are called, these chlorides are called. They're called salts. These are different salts. Now, sodium chloride, everybody knows what that is. That's table salt. So some people use table salt. I can't eat table salt. I just found out I can't eat it anymore. If I eat I can eat it, but it has to be moderate. If I eat too much table salt, I start feeling like I'm gonna die. I have to stop eating it, believe it or not. But that's the idea. So that's where we were trying to go today, to look at what would happen. So let me ask you this. as one big group. Before you have something in front of you. In a few minutes, I'm going to get you to look at it, tell me what it looks like to you, and make all the observations you can. And then you're going to do some basic little observation inference and observation experiments based on it to see if we can make a connection from you using metal in an acid to looking at what happens when you put metal in a salt or in a different solution and see what happens. Now, if I were to ask you about the gas that was formed, do you guys know how to test for that gas? Joshua's hand went up first.
If you light a match and put it to the gas, it would make a pop noise.
A squeaky pop noise, right? That's good. Wow. You guys are ready for the next stage. This is amazing. Okay, so let's unlock this. And let's look at what we're looking at today. You guys can see that with the lights on?
Yeah.
So we're looking at displacement reactions. Here's what you know so far. If I were to ask you this, before we even look here, if I asked you guys, if I had hydrochloric acid in all of these, can you still see this, or is it too dark in it? If I had some dilute hydrochloric acid, because I know you did this experiment. I wasn't here when you did it. I did see another class do it. If I had hydrochloric acid in there, and just trying to remember from off the top of your head, you don't have the information in front of you, and if you really can't get this, I could possibly demo it, but it might take away from the lesson today. If I put, let's say I put magnesium in the first one and copper in the second one, what would you expect to see in the bottom here? Anybody? No, it's except Marquez. Let's give somebody else a chance.
See, the magnesium getting white and ugly.
And white bubbles. Did everybody hear what Eric said? He said that you'll begin to see white bubbles. But here's the big question, because this topic is all about the reactivity series. And we have to be able to say which one is the most reactive, which one is the least reactive. And by least reactive, we mean we might not see any bubbles or anything. So we might not see any bubbles. If I were to, which one of these would you see the most bubbles in? All right, Piande. The magnesium. So that's good. That's where we're going with this. We want to know that you can, if you were given a list of elements, or metals in particular, a list of metals, and they were placed in hydrochloric acid, you'll be able to list them in that order. And you'll have a chance to do some of this stuff in a few minutes. Not necessarily the experiment, but to show me that you can write these equations and list them in the right order. So let's look at this. Is this board live? Is it? Okay, so making the connection. This is what you guys knew. You know that, and Marquez said it. I wanted to have to say that, but he said it. He said that if you put a metal, certain metals, most metals react with acid. Some don't. Not with the dilute acid, at least. You might have to use a more concentrated acid. But if you put a metal in dilute hydrochloric acid, it begins to react. And Kiande and Eric both said, how can we tell that it's reacting? What would you guys know? Katia, say that again.
That was Brandy.
Okay, Brandy.
Bubble up and
You'll
start
begin to see the
sizzling.
bubbles. You guys know, why do you think I'm asking you these questions?
To see if we know and understand it.
Well, that's one reason, to see if you understand it or not. But guess what? We're trying to prepare you for the checkpoint. Not the only reason. I'm going to try to make some real world connections to it. Like, where will people really use this in real life? But on top of that, in that checkpoint, or at least when you get to the GCSE level in your second year of high school, they're going to ask you to write this and explain it. And then not just explain it vaguely, explain it with good English, explain it scientifically. You have to be able to talk about those things, like the bubbles. I will know it's reacting because I see some bubbles forming. I see the little white bubbles in there forming. I'll know this one's reacting more because I see more white bubbles, and so on. You'll have to answer that. I'm sure on any assessment you have later, you'll get more credit. The better you're able to explain this, the more credit you'll get. But that's what you knew. So this would allow you now to be able to predict which metals are more reactive on the periodic table. Another way to do that is another way to make predictions is by looking at displacement reactions. And that's what we're looking at today. So the reactions of metals in displacing others. And the key to this is the metal that's the most reactive is going to take the place of the other. We see it in school all the time. Sometimes we see it. This is the connection we can make. It's not a good one, but it's an analogy. I'll show you where it breaks down later. If we put like all of you guys in a room and we leave you there to see who's going to take charge, one person or a few people would emerge as the leaders in the room and start to tell everybody what to do. And that's just what happens with these type of displacement reactions. One of the substances, let's say what you have in front of you is a blue substance. In a few minutes we're going to ask you to do some stuff with it. You're going to place a paper clip inside of it and then look at what happens and just try to discuss what happens based on what you know about how the metals react with acids. And sometimes, well, not sometimes, but what happens is the more reactive metal takes the place of the less reactive metal, and they switch places, just like what you did with the do now. So let's look at how we write these equations. Okay. Remember from the experiments you did last lesson, that's what I was doing, recalling for you, helping you to recall that. Put these metals in your journals then in front of you. Let's do this. Put these metals in order of most reactive, if you can. If you didn't do it, I'll come around and check to see if you're able to do this. And this is based on your memory or the notes you have in your journal. So let's take 2 minutes to do that and list these in that order.
Joshua, you can get it up for me.
It's underneath your chair. Mr. Swan? Mr. Swan?
So in other words, some people are asking a question. Let me just check and see if the board is live. Okay, guys. Some people are not clear. They just simply wrote the words on the paper. What I was asking you to do is this. You could do it like this. It's a lot of different ways. You can say most reactive, least reactive, and then list them. 1, 2, 3. So the one that you think is the most reactive, or you could have put them in order like this. 1, 2, 3. There's only 3 of them, but you could have listed them without me telling you the answers. Just to see, I'll come around and check and see what you have. Some people just wrote them in the same order. They wrote copper, magnesium, zinc, but maybe they believe that's the right order. I don't know. Okay, so, Zakira, what order did you put them in?
Magnesium, zinc, and copper.
Okay, I'll write that for you, just so we can get to the next part. Magnesium.
Zinc and copper.
Am I able to just write this? You guys know what that means?
Yeah.
Are those the right symbols?
Yes.
Did anybody write it in a different order? Does anybody want to challenge this?
Oh, I put zinc, magnesium, copper.
Okay, I'll put that in a different color. Zinc,
Here.
magnesium, copper. Okay, guys, what do you think? How many people, by show of hands, how many people put magnesium, zinc, and then copper? Okay, let's put those hands down. By show of hands, how many people put zinc, magnesium, and copper? It doesn't mean that Isaiah is wrong. What if he's right? I could do it as a demo, but we'll come back to that. You'll come back to it. You'll probably see what the right answer is without me telling you. You can look back in the experiment that you did and list them. But the truth is, these two are definitely more reactive than copper. We know that for a fact. If you recall the experiment when you dropped them in, you probably didn't see very many bubbles from copper, if you saw any at all. What if I had put this up here? What if this was one of your choices? You guys know what that symbol is? Iron, right? So what if you have put iron in there? How reactive? Which one of the is iron more reactive than copper or less reactive than copper?
More reactive.
More reactive.
More reactive. Okay.
Where's the iron?
It's up here. I'm sorry. It's a little dark because I want you to see the board at the front. All right. So we'll move on. Now, based on that, we're all agreeing at this point that magnesium is more reactive than zinc.
Yeah.
You guys also did some experiments lighting some of these things, right? To see what they look like in air. You didn't put them in pure oxygen, but you lit them in air. And I'm sure with magnesium, you were told not to look directly at it. You guys were telling me that. Okay. Moving along. Now this is the connection that we're making. All metals can be put in order of how reactive they are. This is called the reactivity series. You guys knew that already. Now, what is a displacement reaction? It's very similar to this reactive series. When one metal gets pushed out or kicked out by another one. Let's look at an example. We have iron chloride plus aluminum. Sometimes it might be written this way, aluminum plus iron chloride. If we're looking at the way I gave you the do now, remember it was written like this. You just turn the light on for a second. The do now was written like this, wasn't it? Everybody see this? It said something. It said something like A plus BX. What does this arrow mean? How do we say that in science? Do you guys know? You don't have to know. You can say equals. It's like saying equals, but we use a word that begins with a Y. And especially when you begin to write this on your checkpoint and your IGCSE, you want to use that word. Anybody know? I'll tell you guys today. It's called yields, but it means equals or gives. Because these are products and these are reactants on this side. So we said that this becomes AX plus B. So using this formula, you should be able to write any of these reactivity series type reactions. But we're also going to apply this. This also applies to a displacement experiment. So with that in mind, aluminum in this case represents A, and iron chloride represents BX. What do we think in this case, this example right here? Let's copy this example. You guys write what you think the products will be, what it would yield or equal. What would we get on the other side? And this is not, you notice that it's not, you're not putting it in an acid this time. You don't have a chloride there. You don't have an, okay, actually, you do.
It'll stay the same. It'll stay the same.
Pardon?
It will stay the same.
Stay the same? Okay, write that. Let me see what you have. I might be able to help you that way. So let's write what you think it would yield based on the formula. Based on everybody seemed to get that do now correct. And people pointed out that the answer was already on the paper. But now we'll see if you can write it for yourself. Not just look on somebody's paper. So let's write it out. Let's put iron chloride plus aluminum and it yields. Let's see if you can write what it yields. It'll take 2 minutes to do that. Just make sure everybody actually tries. You can apply this to. So I told you that this is A, B. Okay, stay the same. You will stay the same too. All right, now this is hard, guys. I'm trying to figure out why some people were able to get that do now, which was exactly the same thing as this. Look back at the paper. You still have the do now in front of you. You guys get it? But you didn't explain it to you. No big, aren't you?
It's liquid.
Okay, guys. So let's bring this to the front. Let's help clear it up for some people. Some people actually said it would stay the same. Some people didn't try it. CJ, you have to take the jacket off. Let's look at this. Some people didn't try it at all. So we're gonna speed it up a bit. I was really checking to see what you knew. We said that when one metal kicks out, it gets kicked out by another metal. So here we have some. I asked you earlier about some objects. We had iron, we had copper. I didn't put aluminum up here, and we said along this series, which one is more reactive? So you don't necessarily know this, but based on our experiment, or the do now this morning, this is Bx. If iron is B and chloride is X, and aluminum is A. We said that AX plus BX equals, or A plus BX, I mean, becomes AX plus B. So this would have become what? Guys, you should have been able to tell me that.
Iron plus aluminum chloride.
Iron plus aluminum chloride. Joshua, is that the same? But you said it would be the same, but you figured it out. I'm impressed. You figured out, that's the connection. In a few minutes, you're going to try some more of these. This is what we end up with. Joshua said it. We end up with aluminum chloride plus iron. Alright, so now you've probably been wondering about what that substance that's in front of you.
What is it?
You have to wear goggles for this. You guys know where the goggles are? Where?
Can we clean them first? Yes. Mr. Swan, we can clean them?
Everybody have sight?
Joshua, where's the alcohol? I don't know.
That's right high, I think. Yes, it is.
We have to use one because we're older than this. We're supposed to share. There's enough in here for everybody.
Oh yeah, I'm trying to get this little.
No, we're supposed to try it, babe. That's you. Sure, use this. You use this. You have to.
Alright, guys.
Just use it. We don't have paper towel.
It's not.
No more paper towel. We need some paper towel. So, oh, stupid.
Alright, all of our goggles are clean.
What is this?
Somebody used them today.
It's not taking any oxygen.
Yeah, clean them.
It's not
Is that I need a napkin.
Joshua.
Where's that paper towel of yours?
It's not.
Wow, you didn't finish. Then where's your paper towel?
Oh, someone took it.
Okay.
That's right.
That's on my book.
I don't have any more milk.
Alright guys, this is taking too long. Then we're gonna have to change our mind. I'm gonna bring one of these substances around the front. You guys are gonna have to kind of watch. No, you're taking too long to clean your goggles. I'm sorry. It's not your fault. I should have made sure the goggles were clean. But it's gonna take too long. So let's come closer to the front. And we'll run out of time. So Maya, let's come closer to the front. I can send you guys back after this, but you were taking too long to clean your goggles. We would have run out of time. A simple observation. Here's what I needed you to see. Here we have copper sulfate. You guys talked about sulfates. You talked about chlorides earlier. You want to place this. You want to be able to change the shape of your paper clip and place it in there and look at what happens. Does anybody know what substance the paper clips are made out of?
Iron.
Iron. Stainless steel, but it's most of these are stainless steel, but it's just, that means that it's a metalloid. It has iron and some other substances in it so that it doesn't rust as easily as iron. But it's iron. This is placing iron in copper sulfate. So if we look at iron, that would be our A. If we look at copper sulfate, that'll be our B.
Yeah.
So what reaction do you think we'll get here?
Iron sulfate plus copper.
Iron sulfate plus copper. So here's something that this is the way that we relate this. You guys will be able to go back to your seats and possibly try this too. But the way we relate this is the metal that's the most reactive replaces the one that's the least reactive. Remember we talked about if I left you in this room and somebody would begin to take over, the real leaders would emerge. That's how this is connected to the reactivity series. It's still about the most reactive metal. So in all of these cases, the most reactive metal is beginning to kick out some other metal. So that's what's happening. So now you can return to your seats. I'm going to take this out. If you want, you can even drop the paperclip in there.
You mean
Just
like
a
this?
paperclip.
You just drop it like this?
Right, you can leave it in there and take a look at it. And let's look at by the end of the lesson what happens.
Can we have a paperclip? Shouldn't have a camera phone.
Use your brain.
Dump it in there. No.
Let's examine this fish. Let's take Swan here. Oh no, I'm running low on oxygen. Okay.
You gotta use the paper to get it.
Dropping our oxygen tanks off.
I guess I'm just gonna found it. Be like, yeah, they fall.
No, just be like, let's take some oxygen. It's inside of back.
Hey, look, Marquis. It's Washington.
Oh my gosh, that's so fast.
Okay, so as you're doing this, the thing that you need to write is what you observe. What happens to the paper in words? I did write it for you. I did tell you. It's the same thing.
Oh my gosh.
You gotta find one.
We need acid.
The good thing is you get to see the before and the after if you don't drop the whole thing yet. Only the part that's been in there. It's okay. Only the part that's in there. Both in there.
No, we saw people. Yeah, we want to pick out. This is busted. Look, Sunday, it's your Aunt Frank. It's your Aunt Frankie. Just gonna stir it up a little.
Your arms are good.
What? It's hurting you. Where are they? Oh, there's some. Oh, they look like they've been inside the water, like the sea water for like years.
Been in water for less than a minute.
I remember when they first invented chocolate. Don't wipe it off.
Why not?
You gonna wipe it on your table?
We wipe the tables, fun. Science. Oh, my finger's burning.
What's this substance called?
Copper sulfate, I think. Look, it's completely clean now. Look at it again. The liquid doesn't do nothing to my skin. It just gets rust off it. It's back in, I just threw it back in. Let it rust off. Oh, this one's going completely rusty. Let it rust off. Look.
It's been started to rust. And the other classes.
I can't get the rust off of this
Okay.
paper.
They stay real.
It's my fingers. It smells like metal.
I hate my fingers. Why would you do that?
We keep picking it. It's like it's burning inside.
You guys know what this is?
Hey, it's not roasting no more. Look at it, it's not even roast no more. It looks wicked.
Okay, so guys, did you write your observations of what you saw happening to it?
It's complicated.
You dropped it.
And what is it? Apple what?
Okay, so let's stop what we're doing for a second. All eyes this way. Okay, stop for a second. We'll get back to that in a minute. The important part is that we have to make some conclusions about the metal, how metals are displaced. And the whole time I have alluded to and talked about it a lot. It's all about the reactivity series. It's related in the same way. We need to be able to, on any exam or in reality, explain things to people. You have to be able to say how they react and which one does the react, which one kicks which one out. So in this case, anytime somebody gives you something like this, you should be able to see what's now on the outside of the paper clip. What is that? I noticed. Say it again. Say it again.
Rust.
Some people said rust. Other people said
Copper.
Okay, you guys, I knew I shouldn't have asked you yet. That's not that I knew. That's true. That's what it really is. But other people wrote other things. You just wrote your true observation. People said rust. People said it turned black. But the truth is copper. That's now copper on the outside of that. The copper's been displaced. If we had more time and you stayed here longer, what color was that with that liquid initially? Blue. It was nice and blue. But if you left it long enough, it would begin to look like this. It will probably turn a greenish color, right? It's not going to be as blue as that. But that'll probably take a few more minutes to happen. Or we need a larger piece of, like, typically we would have put some of these in there. But we don't have enough. Don't waste them, guys. Part of it was my fault. I came up here a bit late, so we didn't have this. We improvised. We used paper clips instead. You definitely get to see the copper on top of the paper clips, but you might not actually see the iron now in the sulfate, the iron sulfate. As you can still see it, right? That's true, because it's on top of it. Now what we have here, we're going to look at one more and see if you guys can write this.
It's not anything on top of it, also underneath it. It's not coming off either. But just ready to wipe your stuff up, but now it's not coming off.
Right, that's a good observation. We're going to look at one more before we get into our closing, and you guys complete a closing activity for me. This time we're going to have copper. I'll just write it. And we're going to add copper to silver nitrate. So let's write that in your book first. I'm going to demonstrate it at the front. I'm going to demonstrate it at the front, but I need you this time. This is the last thing you'll write in there before you do the closing activity to see if we can bring all this together.
Silver nitrate.
So we have some copper. I came around and asked you guys if you knew what it was. I placed it in this boiling tube. This is a boiling tube. It's slightly different from a test tube. A test tube is smaller than this. Test tubes you don't usually use to heat stuff. Boiling tubes you use to heat stuff. Just in case. It's slightly different. It's a little stronger than a test tube.
You said copper plus silver nitrate?
Right, here we have some silver nitrate solution. I'm going to add it to this. I'm going to come around and let you guys see the reaction. But I want you, those are the products, I want you to write the reactants.
What was the
That the paper clip was iron. And it was placed in copper sulfate solution. So let's make sure we all have that written. And then use the arrows to see what it yields, because you have to write these products out. This is the reactant. Actually, Alright guys, so I'm going to pour it in. And initially, what do you see? Does anybody see anything? Nothing really, right?
Yes, I do.
I can't see nothing. I think it's
I'm gonna walk around, but it doesn't look that great
Yes, it does.
initially. It just looks a little dark
Coffee looks black. Why looks black?
Wait, it's not
because it's beginning to react slowly. That's true. It's reacting slowly. But I'm gonna do something in a minute. There's different ways to speed up a reaction, right? You guys know some ways to speed up reactions. You can use heat, you can make the particles smaller, or you can stir it. So let's look at what happens when I stir this. I'm gonna stir it and come closer. Look at what's happening. If I stir that, what is the copper starting to look like?
Silver now.
What is it replacing?
silver.
Not the copper.
Silver.
So what's on top of the copper?
I can't see.
Okay, I'm sorry. I'm gonna let everybody see.
Right on top.
Wait, that's silver.
Now, this is how people make fake gold and sell it to you, and then you go to your house and get a bath, and it turns a funny color, huh? They plate it like this. It's just transferring. It's all about ions and
He said that's what he makes.
why you guys wait.
That's like that cell phone. That's like it's a different type.
That makes no sense.
That's a dog.
So guys, what can we conclude?
Oh, you're gonna kill me.
This is what we conclude, guys. Metals that are higher up in the reactive series can displace or kick out metals below them because they are stronger. And that's one way of writing. It's not the scientific way of writing.
Why are you so such a
So that could be CJ trying to show us that same thing.
Gravity.
The people that are higher up on the reactivity series are not going to fall out of their chairs. I'm just joking. Okay, CJ, you didn't hurt yourself.
Lower.
So this is the point. This is how you make that same connection. So with that in mind, guys,
Look, it's the guy from there.
you did see the reaction.
Everyone.
So now I'm going to give you some more of these to try. A bunch of them to try. We'll try the first three. Each person will try the first three, and then we'll share some to make sure that we understood what we were doing, how to write these displacement reactions. These are single displacement. Now some of these are. Okay, well, none of these. I'll do it, but this is the same. This is the same way you would have written when you place zinc in hydrochloric acid. It's the same idea, but some of you still couldn't do it. But hopefully today you'll be able to do it.
What are you writing down?
So before you leave, make sure your name's at the top.
I don't know why.
And let's complete at least the first three. And you'll call on some people to explain why they wrote what they wrote. And I'm going to ask you, what does it mean? Because you should be able to say that the B, let's say like B on the second, on the right hand side, is the reactant, or is the metal that is that's more reactive, or most reactive, or more, yeah, I guess more in this case, but it's more reactive than the one it replaces.
He did a rest for making things.
No, not 80, 170. Let's go. Let's write that.
This is writing a book?
Air out that way, and the air's going, and then the flame going that way.
If you get oil and you make it go this way, and you light it on fire, the whole thing will catch on fire.
Well, I didn't say anything about oil.
Yeah, but that's the same thing with the fart. Well, that's nothing to do with... Wait, what were you talking about? He said if you fart into a fire.
Huh? I said if you fart in the fire,
Exactly, right.
the fire will go that way, not that way.
No, she did not say that. Lion.
An iron sulfate plus copper is.
Oh my god.
The boy's not calibrated. Why did you make one? How do you calibrate the boy?
Only the bread juice inside. I'm talking about outside.
Alright guys, let's wrap this up.
You should turn it off.
We'll continue with this next time.
Electricity.
The vehicle is slightly low. Let's look at the first three. I was attempting to write on the board. I forgot it doesn't work. Right, let's look. Let's call on a few people. Get here. You ready? Iron plus copper sulfate. What would that give us? Iron sulfate plus copper. That's the one we just did, right? We should have all been able to write that. CJ, let's look at copper sulfate plus zinc. What would that give us?
Zinc sulfate plus copper.
Zinc sulfate plus copper. So we're getting this. This is the same idea, just like we did with adding those metals in the hydrochloric acids. Anybody else? One more person to volunteer one? Joshua. Number 3.
Copper nitrate plus magnesium.
Plus magnesium. Wow, so you guys really do have it. Earlier I was worried because everybody had to do no correct, but then when we first looked at this, you didn't get it right. So for tonight, take this with you. Make sure you complete this. Mrs. Bean's going to collect this from you. You need to finish all 12 of them. You should be able to do it now. And most likely you'll be moving on to learn that when you were dropping those acids, and you were dropping the metal in the acid, you were producing hydrogen gas, but you were also producing a salt. So I'm sure you'll begin to make some connections with these salts. And when you drop metal in a salt, you still get substances back. That's the connection. So let's begin to pack up. Let's put all of our goggles back. Speed has to come in. I'll come around and and get rid of, show you how to dispose of this correctly.
Why are you in the bed of good? Trying to bring me
I didn't get you right in your homework, in your agendas, but you know what's going on? We're finished it already. So, put your goggles back. Hey, right, what did you do?
Even at her.
Just sign it, please.
C'est dessus.
Okay, whose goggles is this?